Okay, so today we're talking about simple interest. Raise your hand if you have a savings account or a bank account or something. Raise your hand if you know somebody who has a loan, like say a mortgage, that would be a house, or a car loan, or maybe some other kind of loan. Okay, maybe you know someone who has a credit card. Okay, so all of these things deal with interest. If you have a savings account, you're earning money. It's really small, but you're earning a little bit of interest each month. If you have debt, like a credit card or a loan or something, you're paying interest, okay? And that's called simple interest. There is another kind of interest. It's called compound interest. Compound interest is like each month it resets. So like say you owe this much this month and it resets, you're going to owe more. That would be credit card debt is compounding. Or remember when I told you to invest in the S&P 500, the stock market? That's compounding interest. But we don't learn that in 7th grade. I think you guys get to do that in 10th or 11th grade now. It's a little bit trickier, that formula. This formula is a lot easier to learn. So, simple interest. Let's first define principal, this word. It's not like your principal at your school. It's a different principal. It's, what do you call those, homophones? Like, same spelling, different meaning. So, it's the amount deposited or borrowed is your principal. Okay? So if you deposit $100 into your account, that is your principal. If you borrow $100, it's still your principal. Okay? The amount deposited or borrowed. And then the definition of simple interest is just the amount paid or earned. The amount paid or earned for the use of the money. Okay, so paid would be on a savings account, or sorry, paid would be on a loan or something, and earned is on the savings account. Any questions so far? Has anyone that has a savings account actually looked to see how much they earn? It's really small, right? Yeah. That just means the percentage they pay you is pretty low. So.
They pay you?
There's different kinds of savings. There's like savings bonds, and sometimes those can make more money. There's certain kinds of savings where you could put in to the bank, and as long as you don't touch it for like 10 years, you don't take any money out, they'll actually pay you a greater amount of money. Have you guys heard of 401ks, retirement savings?
Yeah. Oh,
yeah, so if you don't touch it, then you end up making a little bit more. The bank is kind of like, they like people to put a good chunk of money in and leave it for a while, and so they'll pay you a little bit extra, reward you for doing that. The banks do that. Okay? So if you're paying it, though, it's like you have a loan, right? So you're going to pay a certain amount, or a credit card, you're going to pay a certain amount of interest. It's the same idea, though. Okay? The formula looks kind of weird, so I'll break it down for you. It's just a bunch of letters. It's I for interest equals P for principal times R for rate. That would be the percentage, and T is time. So the interest will be equal to the principal times the rate times the time. So again, the principal is like your original amount that you put in or borrow. The rate is a percentage. We're going to change those to decimals. And time is how many years or months. If you're given months, you have to change it to years, though. Okay, let's look at an example with numbers so it actually makes a little more sense. Okay. Let's say that you put $580 in the bank. and you don't add anything else to it. You just put the 580 and leave it there for 5 years, and the bank decides to give you 3% interest. This would be high, but let's just say they did. And we want to figure out, okay, well, how much are they going to give you? How much will you earn? So we're solving for I. So I equals, the principal is 580. What's the interest there as a decimal?
0.3.
Not 0.3, but
0.
0.03. Good. And if you forget, see up on the board there on the right-hand side, it still tells you like percents to decimals. So 9% would be 0.09. Remember moving the decimal place 2 places to the left. Okay. So now you just take 580, and you would put that in your calculator times 0.03 for the 3% times 5 for 5 years. So raise your hand if you think it's going to be a lot of money. Raise your hand if you think it's a little bit of money. Raise your hand if you have no idea. Let's find out. So if you put that in your calculator, you get $87. Who thinks that's a lot of money? I think it's kind of a lot of money. All you had to do was put your $580 in there and leave it there, right? For 5 years. Probably forgot about it. Okay, so that's how much the bank would actually pay you. They would pay you $87 at the end of the 5 years. Okay? Unless you had some sort of compounding interest deal, then you could make a lot more money, but this is a regular flat rate, simple interest. Yeah?
If you had compound loans, like, would you make twice in a row? Or
If you had what?
the compound one you were talking about?
So compounding is exponential. So it starts off really small, like you're making a little bit, but each time, like, think of something, a number doubling. You know how after a number doubles so many times, all of a sudden it's like really big? Okay, it's like that. Have you guys ever done that math problem where they say, would you rather get a penny a day for 100 days or $100 all at once? Remember that? You ever done this problem?
Yeah.
A penny a day for 100 days or just $100 all at once? And a lot of people take the money all at once, but then they realize that the penny a day is like it works out to over $1,000.
If you did a penny a day for
Yeah, but I'm saying,
That's $1.
or
that's what the
$100.
but each day you add another penny. So on the first day you get a penny, then the next day they give you 2 pennies, and the next day they give you 3 pennies. It's kind of one of those things. It's called exponential. Okay, it's like a little math riddle they give you. No one's ever given you this?
Nope.
Oh, darn. I guess I can't give it to you now. I just told you the answer. All right. Let's try another example. Very similar numbers. I'm going to use the same numbers. The only thing I'm going to change is the years, okay, the time. So you don't have to write that amount earned thing unless you want to. But so let's say you still have $580, but you only leave it there for 6 months. Okay? So it's still 580, it's still 3%, but this time it's only 6 months. So obviously we're going to make less money, right? Everyone understands that. Less time, less money. Okay? But here's how you do the math. So 6 months is what as a decimal in years? We just did it in the warm-up.
0.5.
0.5 because it's half a year, right? So in case you forgot, it's right there. 6 months is 0.5 years, half a year. If you forget those numbers, you can look back at that warm-up page on 166, but you'll get a hang of this. It's pretty simple. So now we have to multiply all this again, but instead of doing 5 years, we're multiplying by 0.5. Okay, so obviously we're going to get a smaller number. We're going to get $8.70. So yeah, it should be less, right? It's only 6 months. So the most common error that people make when doing these is that they are not changing their percent to a decimal correctly. So they might get like the numbers right, but maybe they'll have $870, right? So you have to be careful that you're changing that percent to a decimal every time. Any questions on this one? Does everybody understand the 6 months being 0.5 years? We've been doing a lot of decimals, right? A lot of fractions, so hopefully you guys are okay with that. No questions? Is anyone thinking about opening a savings account now? Or at least putting some money in there? Maybe?
It's all maybe.
Too bad the bank gives you like 0.003%. Yeah.
So what if there was like 7 months out of 12? Well, 7 months.
So if say it was 7 months, you only put it in. So you just 7 divided by 12 and you'll get some decimal. Point something. 7 divided by 12, I don't know. 0.6, close to that. Okay? Alright, let's look at one more example. Now, let's say like you put the money in, but you want to know the total or something like that, or you borrow money, you want to know the total you have to pay, not just the interest, but the total. So let's look at this credit card situation. So this is the last example here. So let's say you have a credit card and you put $900 on it. Credit cards have really high interest, so 19% is pretty accurate. And let's just say you don't pay it off until the 2nd month. So 1 month has gone by. And you want to know, oh man, how much do I owe now? Okay? So you have $900. What's 19% as a decimal? 0.19, right? What's 1 month? 1 over 12, right? So 1 over 12 as a decimal. You have to figure all that stuff out. So here it is. So 1/12 of a year is 0.083 repeating. Okay? So do that first so you know. And then when you plug all that into your calculator, you take the 900 times 0.19 times 0.083. So after 1 month, this credit card, the interest they're going to charge you is about $14.25. I'll stop right there, let you guys get that written down. So for 1 month, which is 1/12 of the year, times 0.19 times 900 is $14.25. So who knows the total now? What would I owe after a month? Would I owe $14.25?
No.
No, what would I owe?
$914.25.
$914.25. Does that make sense?
Yeah.
So I put $900 on the card and I haven't paid anything yet. So I have to pay the interest plus what I put on there, which is called the principal, right? So now to get the total, so if I ever ask you for total, like in your homework, you're going to see that today, then you have to just add them together. Okay? It's kind of like common sense. That's not so common, right? So I spent $900, but now I owe that plus the interest. Now the reason I only put it for 1 month is because credit cards are an example of compounding interest. So if we did it for 2 months, we could do it, we could figure it out, but we would have to use the $914.25 as our principal. Because each month you're adding a little bit. Does that make sense? So you're not adding $14.25 each month, you're going to add a little bit more. It's just going to grow and grow and grow. So the formula for compound interest is pretty tricky. So has anyone ever used Excel in here? Like you made a spreadsheet with Excel and you had to sum? No teacher ever made you do that? You guys know what Excel is?
Yes.
Okay, so it's where you like punch in numbers and you can set it up to total your columns? Never. Good. Well, that means we'll have to do one of those. So there is actually a compound interest formula that you could put in there, so you don't actually have to do this yourself by hand. You could just punch in that, or online. There's these compound interest calculators, things like that. Okay. But it is tricky. Okay, so I want you guys to try a couple of these just to make sure you're punching in your calculator right. This one I just want the interest, so let's say you start with $1,500. The interest rate's 4.25%. Be careful when you change that to a decimal. And it's 4 years. if you can get that one. Does anybody think they have it yet? You do? You think? You think you have it? Okay. So let's look at this one. Okay, so we have 1,500. What's 4.25 as a decimal?
0.0425.
0.0425 times 4. So double check that you did that. And then we'll put it in the calculator. 1,500 times 0.0425 times 4 is $255.
So credit cards can go up very fast.
Well, that would not even be a credit card because that's still simple interest. But yeah, I mean that's how much interest. Say like you borrowed money from a friend or something like that, you'd owe them $255 extra. Okay, or a car loan. Car loans are simple interest. All right, let's try another one. So we have $580 times 2% times 6 months. Okay, so don't forget you have to convert your 6 months into years, which we did in, I think example 2 we did that, didn't we? So you have something to look back if you need to. So try that one out. Some of you either appear to be doing this by hand or you don't like your calculator or something. It's weird. I see a lot of calculators just sitting there. Did you already finish? Okay.
Oh.
So much. Try it out and then raise your hand if you think you know. 2 people think they know? 3 people? 4 people think? Well, it's okay. I said think, right? Not sure you know, but think that you know. Georgia, what do you think it is?
$5.80.
You're right.
Ooh.
$5.80. So some of you got 5.8 and you didn't know what that meant. Well, it's money, right? So it's $5.80. Okay? So here's the setup. The setup is 580 times 0.02 times 0.5 for the 6 months. And you get 5.8, which is $5.80. Who got that right?
5.8.
Who got 5.8 and just assumed they were wrong because it didn't look like money? Yeah. So just, add a 0. You got it. Good job. Okay. We're going to do 4 more problems, but they're in your book, not in your notebook. Just to make sure you got it, and then I'll pass out the homework. So it's on 173, 18 through 21.